All right, so this question says, in a science fiction novel, the main character found a mysterious rock that decreased in size each day. The table shows the results. Assuming the rock decays exponentially, use the resulting information to answer the questions that follow. And the questions that follow wanted us to determine the size of the rock for x is equal to 1 and x is equal to 3. So, as usual, we want to start by just really pulling out the important information. What do we know? Well, we know that this is it's decaying exponentially, so we know we're going to be dealing with an exponential equation. And then the initial value occurs where x is equal to 0, so that's 200. So that's enough information for us to start with the equation in exponential form. Y is equal to a times b to the x, and our initial value. We know it's 200, so let's figure out what the growth factor is. Well, it's actually not growing, it's decaying. So what we notice is it's being halved, so multiplying by a half each time, because 100 is a half of 200. If you look at 50 is a half of 100, so it's being multiplied by a half. So in this case, a decay factor is actually 1/2. So the equation that represents this context is y is equal to 200 times 1/2 raised to the x. So that's the first thing we want to establish. All right, once we've done that, we can move on to using that information to finding values of the size of the rock when x is equal to -1 and x is equal to -2. And if you're thinking about it, okay, if you're going back in time, because a negative means before the initial value was found, what does that mean? All right, so let's continue. So as I said, we know that the equation that represents the current situation is y is equal to 200 times 1/2 x. We're finding the value when x is equal to -1 and x is equal to -3, sorry. So the way we set this up is y is equal to 200 times 1/2 raised to the -1. Remember, we said that negative exponents, when we see a negative exponent, we know it represents the reciprocal of our term that is being raised to that particular exponent. So the way we do that is we take the reciprocal, which is flipping it. So y is going to be equal to 200 times, what's the reciprocal of 1 over 2? It's 2 over 1 raised to the positive power. So y is going to be equal to 200 times 2. And the way you multiply fractions is you do top times top, bottom times bottom. So y is equal to 400. So what do we know right now is that when the rock is, it's -1, the size of the rock is going to be 400 milligrams. They've asked us to also find it when x is -3, so we're going to do the same thing. Y is equal to 200 times 1/2 raised to the -3. And again, what we know is that -3 tells us to take the reciprocal of our base number, or sorry about that, the reciprocal of the growth factor. So we're going to flip that, which means that this will become y is equal to, I want to keep my colors consistent. So y is equal to 200 times, what's the reciprocal of 1/2? That's 2 over 1, and we're going to multiply that or raise that to the positive power now. So that is y is equal to 200 times 2 over 1 is the same as 2. So that's 2 times 2 times 2. And we simplify the exponential piece. 2 times 2, that's 4. 4 times 2, that's 8. So that's 200 times 8. And when we multiply 200 times 8, then that is going to be equal to 1600. So in this case, we know that y is equal to 1600. And what that really means in this case is that in 3 days before before the initial time, the size of the rock was 1600 milligrams. A day before the initial data was represented, the size of the rock was 400 milligrams.